my picture looks great now. I came up with intersecting points at using the rational root theorem anyways. Well, after maybe a couple pages. Pi halves. And then these guys. So I guess here and there. Humor me, is that what you guys came up with?
Yeah.
Right there. Yes, sir.
I thought when you said approximation, you wanted us to draw the picture and then look at her picture and try to guess.
No. I said, tell me if I'm wrong, you guys. Use no technology to complete this quiz with the exception of the approximation of the final step. That's a very final answer. So let's scroll down again. I'm sorry, you guys. I'm going to make you dizzy. Did I ever look at it? Oh, here it is. Here's the integral. So there's my integral. I anti-differentiated. Oh, shoot, now all the work comes. Now, without technology, I've got to come in and actually evaluate this business. I just can't because everything's in terms of x, and I need to rewrite it in terms of sequence. So I applied multiple trigonometric identities. Right?
So I use the identity sine of theta is equal to pi over 2 minus theta?
Yes.
Or cosine pi over 2 minus theta?
Yes.
Does that work? Is
Yeah,
that all
I
right?
think I did. That would be fine.
Okay. I got the same answer. So.
You know, guys, I could have cleaned this up further. I suppose I could have, I don't know, multiplied it here, then multiplied this in as well. It just got too sloppy. I just stopped there. I don't know where you stopped. I'll check it, don't worry. Anyway, for what it's worth. But gosh, you guys, that took me several pages to write. Can I close this? Okay.
So when you give us like the interval from 0 to 2 pi over 3, it means like we have to find the 2 and
Ma'am, when somebody had me look at theirs this morning, I think I wasn't very good with my English. I think I could have done a better job saying what I was asking. I should have said, look at the picture over the interval from 0 to 2 pi thirds. Now, over the interval, there's some bounded region. Compute the bounded region area. That's what I meant, instead of going from 0 to 2 pi thirds.
Can you scroll up to your,
Yes, I can. How far?
to the actual graph?
Yes. Whiz on up there.
And then when you mean bounded, do you mean everything that's...
I think from 0 to 2 pi thirds, here is the only region in between that's bounded by those curves. Oh, but shoot, that means I gotta take a break and find the x-coordinates of these points of intersection because those will be the bounds of integration when I set up my interval.
So the two before and after, or the one before and after aren't bounded while the two curves?
Yeah, I assume that the 0 and the 2 pi over 3.
Yeah, that's why I'm saying I think I did a fairly poor job in wording that. I meant to say over the interval from 0 to 2 pi thirds, there's a region bounded in there. You can do this volume.
Alright.
Don't worry about that. It's not going to kill you.
Yeah, because when I was thinking about it, I thought about it different. I thought about, well, okay, those graphs are going to keep going on and on and on forever. So technically, all those regions are bounded.
Because if you interpret the question that way, all of them. I just think it did a lot more work than I did.
Oh, yeah.
Because I just computed the value of one interval, you could do three of
You
them.
into three integrals, and that's what I ended up doing.
I can live with that. Anything else for get rid of this? You want me to get rid of it, don't you?
What were the bounds again?
Actually, you know what, sir? I don't remember.
It's
I came up with
pi over 10 and pi over 2.
a power of 10.
Yeah, it's pi over 10.
Really?
Yeah.
Yeah, I got 5 or 10 also.
I'll have to check it out because I think I came up with this.
I think that probably equals pi over 10.
Yeah.
All right. But I'm happy. You guys, how about homework? Any questions?
13?
What section are we in, Brandon?
6.4
6.4.
or 6.3. 6.3.
6.3, number 13. 6.3.
And I had a hard time visualizing the first couple ones. The 13. Can you do 11?
I hope I can. Alright, you guys, let me get settled. Let me see where we were at.
Was it 7:51, I think, is where it started, and then, like, the 9 or 11, it started at the
Well, I'll skip around, I think I'm probably first. Yeah. Let's see.
So just with the picture,
Yeah, I just didn't know what it was.
like with the
trying to ask.
tetrahedron?
Yeah.
Let's see if you graphed it the same way I did.
Oh, can you stop? Was it all edges had length 4? Hold on.
Yeah.
Yes, I read it correctly. Like a 4-sided die. As far as the picture's concerned?
Oh, okay, I see it.
So is the bottom of this a square, or is it?
No, each and every side is a equilateral triangle.
So where's your X and Y axis?
Oh, that's a good question. I didn't put them on there yet.
Okay,
I'm just saying that's the actual shape.
okay.
Somebody asked me to deal with the shape.
Yeah, and then, cause, the shape itself was one thing, and then somehow they derived a formula from that, and I wasn't picturing that at all. So how do you, cause I understand revolutions, we dealt with that last,
Yeah, but you know what? This is not an example of a solid that's generated by revolving some two-dimensional image about some axis. So I would not consider this solid a solid of revolution. But this is an example where maybe you want to use some calculus and talk about how to compute the volume. I just can't do it. I can't answer the question until I make a decision on where I'm going to place my coordinate axis system. Now, I think since it's convenient, is to maybe place the x-axis, I don't know, sounds convenient right here, and a y-axis here. So now, if you guys don't mind, can I, with my green pen, can I just consider this triangular base for a minute? I know I can't draw very well. Can you see that triangular base? Now, if I were to instead rewrite my x and y axes kind of the traditional way you did back in Math B, oh, horizontal x-axis, vertical y-axis. Since I already used a blue pen to draw that base triangle, somebody's confused all these colors. Let me consider that base. Looks like this, doesn't it? Oh, by the way, each of the sides lengths are 4. Which means if I really wanted to, I can think of the equation on line segment as portion of the equation on line whose equation is y equals
One,
We're all
or
math
just X, Y equals X,
I can't
Y equals X.
I can 1/2 x.
1/2 X. Oh, cause,
Right, you okay with that?
yeah, I got it.
And by the way, all the cross-sectional slices are nice clean triangles. That was a question, not an answer. Should they? 'Cause
Wouldn't they be-
I think if this top edge has length 4, when it comes up off the board, it's not gonna go, I mean, where's it gonna end up with? Where's it gonna be?
Wouldn't it be right triangles?
Let me put it this way. With my black pen,
Oh, if you go all the way down.
here's a horizontal sliver. Do you think coming off the inboard is a nice nifty little triangle?
Yeah.
Always? So I think the answer is no, because I think when it comes to that top edge, which I'm gonna trace with my black pen here, this edge right here, I don't think it goes quite as far as this position right here. Or if it does, you've gotta check it. Do you see my point? Okay. I think it'll come up to a position here, which means the cross-sectional slice is gonna change beyond that value of x. Now, if you didn't finish that problem, can I just stop there and have you get more practice with it? For you to understand, the cross-sectional slices coming straight down are not all the same. They're going to change somewhere along the way. You need to figure out where the heck that is. That's my warning to you if you really are putting your x and y axes the way I just did.
my brain hurts.
Really? Your brain hurts because I don't do a good job drawing. I haven't drawn a complete tetrahedron.
No, I understand the concept of it from that particular drawing. I just don't understand because it's saying use calculus to find volume, and we, as far as I can't think of any way to do it. I don't
Alright, now if I say this, you guys watch me. Triangle coming up straight off the inboard, straight off the inboard, perpendicular to it. Consider the vertex up here, connect there. This triangle is right above this line segment in blue. Is that my tetrahedron? See, I think the answer is no. Because I think that suggests this face right here is perpendicular to the board. I think it's slanted with that one.
So you're gonna have a point in the middle
The
where it
point's
all
gonna-
just
well,
kind
maybe not in
of
the middle, but somewhere in
peaks.
between this extreme x value and that extreme x value. Somewhere in between,
it'll
not in
just
the middle.
peak there.
It's gonna peak out right here. And that's why I'm saying, you guys, I can't do a very good job drawing. But where my fingertip is right now is where this vertex is right here. I'm just suggesting this face right here is slanted in a little bit. It's not vertically up. So I think now, David, to answer your question, to use calculus to compute the volume of an object, let's just take cross-sectional slices like here, 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 and here, and add them all up. But when I take the limit of adding them all up, when I take the limit of that Riemann sum, oh, jeepers, that's just a definite interval from A to B. Where A clearly is 0, and B is clearly is. Oh, you guys, please help me. B clearly is somewhere over there.
Well, because that's what's confusing, because from what we learned, it was you're rotating something about something.
It's the height of the base triangle.
I don't.
No, I think it's one extreme value of x on the red axis to the other one with this extreme x value.
But there's no curve. I mean, and it's
Doesn't matter.
tuning out.
This is an extreme x value. I think I'd be summing up the volume of the objects as x ranges from this position 0 to this position here.
Using what equation now? Because you all you have there is 1/2 x, and then you still have.
Isn't this an equilateral triangle?
Yes.
Yeah.
So isn't this a 30, 60, 90 triangle?
Yeah.
And so I think this x value is a cosine of 30 degrees times 4. Bless you, isn't that just 2√3? So I think in the end I'll be integrating from 0 to 2√3. Clearly? Not clearly. Well, I do this. Give up. Will you buy this? You don't like what I spouted off in English? Don't listen to me. This length is. This length is. Ah, but 4 squared has got to be equal to 2 squared plus this length right here, squared. But doesn't that mean that question mark is equal to square root of 16 minus 4, which is square root of 12, which is 2√3? Isn't that what I just said a moment ago? If you don't like my trigonometry, don't listen to me. Just go to use a Pythagorean theorem from high school geometry. This is mathematics. There's so many different ways of coming up with these values. Oh shoot, we're still not done. I think there's a value of x here for which I'm going to split up the integral, because right above this position is going to be the vertex. That's positioned right here. And now you need to see how you're going to divvy up into 2 different regions. So let me say that much to get you started, David, and you can give it another shot.
Okay.
Gosh, you got a lot on this list. I don't have my glasses.
That's fine. This is one example.
It's 11, 13, first couple pictures.
I have a question about this.
Yes, sir.
So would we keep taking the slice dx? Would we keep taking that once we reach the center point?
Well, you used the word center point, but you really mean the value of x below that vertex that I've not drawn.
Yeah.
I agree. You're still going to look at cross-sectional slices to the right of it as well. It's just they're going to be different cross-sectional slices.
So they won't be triangles though?
Oh, absolutely not. What are they going to be? I guess I can sit for a while. I asked, what are they going to be? What kind? Be more give me another adjective in front of there. Isosceles.
Trapezoids?
Trapezoids, thank you.
So we don't have to do anything different mathematically, we just take it
Hugely.
straight through.
Hugely different, because I think the way you and I compute the area of an isosceles trapezoid is different than the way we compute the area of those triangles to the left. So I do think it'll be different. Yes. Now they got the shapes, give it a shot. I'll do it if you like, but I don't wanna waste it. That was a good question. Did you understand what they're trying to suggest in number 11? If you have your book. Be honest with me, let me read it out loud. Be honest, tell me if you can't put this together, we'll put it together. And then you can finish. The solid whose base is a triangle with vertices 0, 0, 2, 0, 0, 2, and whose cross sections perpendicular to the base and parallel to the y-axis are semicircles. Yes or no, are you able to put it together?
I think I got the picture correct, but the math wasn't coming up with what was in the back of the book.
Oh, really?
Yeah. The way I drew it was, I guess it would be like a sail with the wind blowing in it.
That's kind of nice the way you put that. But I'll be honest, when I read it out loud, I wasn't that careful with the points. Can I look again? I don't remember the points. 2, 0, 0, 2. So 2, 0, 0, 2. Was it 0, 0? X-axis, y-axis. Here's my triangle region. It's just that, I really do have to be careful with my choice of words. It's just that the cross sections perpendicular to the base and parallel to the y-axis are semicircles. So it's sort of like I got a semicircle here, a semicircle here. I think globally speaking, I've got small semicircles to the right, but larger ones to the left. I know I can't do a good job drawing. Do you see? Can you imagine what that looks like? Yeah.
So,
What about a cone? It's more like an object that kind of looks like this. All right, something like that. Something like that.
so
Yes.
well, I got tripped up on this one is, the way I wrote the formula is volume equals on the integral from 0 to 2, 1/2 pi times 2 minus x squared. But the book wanted it 1/2 pi times 2 minus x over 2 squared, and I'm wondering why they have that over 2. The radius.
Can you just work this problem out? I'm completely confused.
Are you really? Brad, let's just dive into it. And then maybe
Okay.
you can, if I don't answer your question, tell me.
Okay.
First things first. Do you guys think you can conveniently give me an equation for this line segment?
Negative x plus 2.
Negative x plus 2, I like that. Or 2 minus x means the same thing. Can I draw this a little bit? Can I not draw the whole thing? Just consider, how about an arbitrary red vertical sliver? Where I can think of this point right here as x of I comma y sub I. But technically speaking, I'm really trying to compute the volume of an object in three-dimensional space, which has a quality. That this is sort of like a diametric distance. I'm looking at a semicircle above it. Looks like that. By the way, it's supposed to be a semicircle. Doesn't look like it. Stop laughing. And so I think, to compute the volume of an ice sliver, I'm simply going to be looking at the area of a side face, which is the area of a semicircle, which is nothing more than pi times the radius squared. Oh shoot, that's the area of a circle. I meant the semicircle. And by the way, I'm going to multiply this by the width of that sliver, but technically speaking, I think this is a small change in dx direction. I think the width of that sliver is going to be a delta x. That's significant. That's important because it tells me exactly how to rewrite the radius. The radius is going to have to be expressed in terms of the variable x. Let's give it a shot. I think this is 1/2 times pi times the radius squared times delta x. Let's just take a peek at what the radius is. Everybody watch. In my picture, is the radius of the circle x sub I or y sub I? Which one? Neither. I think the radius is half the vertical dimension.
Radius should be 2 minus
I think
x.
it'd be 1/2 y sub I.
Why is it 1/2?
Because if this is the center of the circle coming up the inboard, I think y sub I is its diameter.
Okay.
I think 1/2 of that will be the radius.
Okay.
You're happy with that, Brad?
Yeah, I guess I'm just kind of visualizing it
But you
differently.
guys, I think I'm in trouble. I really do, because look what I just wrote on the board. Darn it, I'm gonna eventually take the limit of a difference quotient. I misspoke. I'm gonna take the limit not of a difference quotient, of a Riemann sum. And I know eventually that delta x is gonna become a dx. Ah, shoot, that means I have to pledge my allegiance to the flag, which is in terms of x. I need to rewrite y sub I in terms of x sub I. Let's give it a shot. Got 1/2 pi times 1/2 times my y sub I squared delta x, where y sub I in terms of this equation on the boundary could be interpreted as 2 minus x sub I. Now, Bradley, when you rattled this all off,
Yeah.
I mean, I wasn't careful to do numbers of where they were, but now when I take the limit of the Riemann sum, here's what I generate for my integral. So I want a yes or no answer. Is this matching up with what you rattled off?
It's matching up with the book. I was just,
Okay.
yeah, it's the, where you did the x sub I, or, yeah, x sub I divided by 2, or,
Hey, you guys take this with a grain of salt. I'm actually slamming this on the board different than the author of your text. He likes to say, just immediately think of the volume as the integral from a to b of some area function and integrate respect to the variable x. And that's fine. You're going to get the same thing I do. I'm just lazy. I like to take a look at smaller pictures first. By the way, I messed up, didn't I? I forgot my bounds of integration. Is that 0 to 2? My apologies. So whoever asked me to actually generate this from scratch, is that okay? Not that I still failed. I mean, I need to evaluate the integral, but that's not bad to evaluate.
I actually found what I did wrong. I
Okay.
forgot the 1/2.
As long as you see it. That's all I care about.
so if we didn't put the 1/2, it would make like a cone, right? Or a half a cone?
Yeah, I think you just make a larger radius. It's sort of like the
Yeah.
centers of the semicircles are running along the line instead of the boundary of them.
Okay.
It was just
Yeah.
same shape, but elongated.
Yeah, I think I just misread the question, because I totally see that now.
Oh, it sounds like we're happy. Yes, sir.
Number 9, can you at least explain how it's laid out on the axis?
Number 9, number 9, number 9. Bad Beatles song. So I've got a solid with a semicircular base of radius 5, whose cross section is perpendicular to the base, parallel to the diameter. Don't listen to me. I'll say it again more slowly. I got a solid with a semicircular base, whose radius is 5. Whose cross sections that are perpendicular to the base and parallel to that diameter are a bunch of squares. So coming off the board, I got a square. Here, coming off the board, I got a square. Another square. Another square. So globally speaking, you guys, doesn't it sort of look like this? Roughly speaking. Where again, the cross-sectional slices parallel to the space on the left-hand side and perpendicular to the base in the bottom, which is a semicircle, are all going to be squares. I think that's what the picture would look like. So now the question is how to set up your axes and looking at cross-sectional slices, etc., etc., etc. I probably would have set up the x-axis this way with my red pen. I think this would be the easiest. And my y-axis, right along that bottom edge. That way it can come off the xy coordinate plane, just computing the areas or the volumes of these rectangular solids where one of the faces is actually a square, more specifically. Come on, you guys help me. Are you happy?
What,
Yes.
what is the relevance of, knowing how to do this? I mean, drawing pretty pictures is fine and all, but how does that relate to?
I think it's beautiful how.
Explaining this section in particular.
I don't think it's used to explain this section at all. I think what's really going on is that now that you've been introduced to integration as a technique, particularly value definite integrals, we can apply this by computing volumes of four-dimensional objects that you just weren't able to compute volumes of with your standard high school geometry. Look at that shape of the board. Not that I can draw well, but that's pretty sophisticated relative to what you were able to do back in high school geometry. I think that's the point. Matter of fact, if you can just hold on for one more semester, next semester I'll give you other techniques for computing volumes of solids in three-dimensional space. I just might have to consider a completely different coordinate system, not a rectangular coordinate system, but sometimes a cylindrical coordinate system, or maybe even a spherical coordinate system, where I don't have x and y's and z's, but maybe rhos and phis and thetas, whatever they are. So we'll even get better at this idea of computing volumes of solids in free space with a bit more calculus. Oh, by the way, I can even go into higher dimensional space next semester, not just free space. Happy? It's interesting. You guys have not asked one question today on the washer or disk method. Does that mean you're not caught up, or is it just too easy?
That means it's easy.
It's easy.
Yeah.
Very nice. I'm
Yeah.
impressed.
Oh, I did have a question.
Yes.
Well, there was number 21, I believe. I wasn't sure. I think either the book has the wrong answer, wrong assumption.
Oh, this book's never wrong.
But there's a problem in there where they assume that that equation, the sine or the inverse of that is sine inverse, and 1/4 root of 1 minus x squared is not sine inverse.
Yeah, but when you square it, it becomes 1 over the square root of 1 minus x squared.
Oh.
It's antiderivative, it's inverse sine function. All right, we're happy. Yes, Linda.
On the number 35, I got half the volume that they did. I don't know why they got it. I'm not quite sure.
So when you graphed this, did you get a circle or a quarter circle? That's where the problem is. Because I think the answer is neither. See, when I consider looking at this particular region of two space, if here's the x-axis, here's the y-axis. X being equal to 0 is just the y-axis. That was a math question. But I think the graph of this equation, if you square both sides, it's just a circle whose radius is 4. Half, where'd you get half? Ah, so you're saying walking backwards from here to here, if I take the square root of both sides, I have to have a plus or minus component? And I don't. I only have x values that are positive, so I only get the top half of the semicircle, right? Where's the bottom one? I forget. Which one is the top or bottom? Which one? Which one? See, I think it's neither. I think it's neither. If x is positive, I think that means we get the one to the right. Do you see that, Linda?
Yeah, that's what
So
I
now
got.
oh, it is. I think you said you have a quarter of a circle.
Oh, I guess. I was just thinking the upper part. Never mind.
Okay, you see where the issue is.
Yes.
That's why I wanted to draw
That's
that.
actually my graph. And
Oh,
I
is it
just-
really?
Yes.
Ah,
But I
jeepers.
only considered the part in clutter. I'm sorry.
Yeah, that's quite all right.
Yeah.
As long as you see where things are at.
Yes.
Oh, you guys, let's take a break. And let's
But
just,
I'm thinking, between the x-axis and